AAA on ICE almost sounds like a drink that we could create. In this video, we're going to take a look at using the Identity Services Engine as a Radius server for back-end authentication of user requests, including setting up and preparing the environment for 802.1x. Let's begin. I'd like you to consider with me how much leniency we give an average computer on the average corporate network today. For example, let's say we have this PC, it's physically connected into a switch, and let's say we have an Active Directory environment with Microsoft Active Directory. Now, we think we're pretty secure, and we may be to some point, because a user would have to authenticate before he had access to the resources inside of the Active Directory. However, what would happen if somebody took a CD, a live CD, I guess that could be a donut or a CD, and it had Backtrack on it, or Kali Linux. And this could be done by someone who has broken into your facility, or by an employee who puts the CD-ROM in the computer and then boots off that CD. Now, hopefully we have some policies in place on the computers that are going to limit the ability to boot from a device other than the primary hard drive. However, once again, many companies don't have those controls in place. So if somebody boots off a Backtrack or Kali Linux CD, what could they then do? Well, because they're directly connected to the network, if this port on the switch is in VLAN 10, they now have access to VLAN 10. If the port is misconfigured so it's dynamically able to negotiate a trunk, the attacker on Backtrack or Kali Linux could run tools like Yersinia, negotiate a trunk, and then have direct access to VLAN 10, VLAN 20, VLAN 30, etc. that are available on that trunk. But even without that negotiation of a trunk, they still have access, and they could start doing a scan from this PC of our network. Now, hopefully, we have some cool things in place like intrusion prevention and detection systems that would be identifying a scan and setting off alarms. But I want to warn you, once again, that most networks do not have those precautions in place. So we might ask, what is to be done? Well, we could go ahead and first of all make sure that our computers are not able to boot off of CD-ROM and alternative media, and having passwords on the BIOS settings so they couldn't change it to do that. We could do a better job of not allowing our switch ports to dynamically negotiate trunks, and you and I could take our security to a whole nother level by implementing 802.1x. And here's the magic of 802.1x. We're going to go ahead and not allow virtually any traffic in this switch port at all until we know who that individual or computer is. And to pull this off, we have three different players in the 802.1x game. We have a device called the Authenticator, and in this case it would be our switch, or for coming in wireless, it would be the wireless LAN controller that's managing the access point. And playing the role of the Authenticator, the switch can say no, like Nancy Reagan many years ago, just say no. It's going to say no to virtually all types of traffic that might try to come in on this switch port until we have additional information about what is hanging off of that switch port. On the back end, we have an authentication server. And the authentication server could be Cisco's Access Control Server, ACS. It could be Cisco's Identity Services Engine, ISE. Or as we like to call them, ICE, baby. And the language of love between the authenticator, in this example the switch, and the authentication server, whether it's ACS or ICE, is very likely for user-based authentication going to be using the protocol called Radius. And in the case of ACS, we have two options. We could use TACAX Plus or Radius, or in the case of ICE version 1.2.x, which is currently where we're at, it only supports Radius. It doesn't support TACAX yet. And our third player in this game is the software that's running on these devices, and that's called a supplicant. And the supplicant might be built in. For example, most versions of Windows have a built-in supplicant, or we could add software to a device that would perform the role of the supplicant. And the supplicant's job in 802.1x is to supply And what it's going to supply is going to supply credentials. So let's say, for example, that this machine is where Bob is, and Bob has a password of nugget bang23 like that. The supplicant could supply that to the authenticator. The authenticator could say, hold on a second, I need to make sure that's all good. The authenticator using Radius communicates with the backend server, whether it's ACS or ISE. In the case of ISE, it has to be Radius, to verify whether or not the credentials supplied are correct. And then the authentication server can send a 2 thumbs up message back over to the switch, who's our authenticator, and then the switch can go ahead and open up those ports and allow Bob's traffic in. So now check this out. We have the ability to control right at the switch port whether or not traffic is allowed into our network. So if somebody comes back and they boot up off a Kali Linux or a Backtrack CD, if they don't have a supplicant that's supplying the correct information, they are not going to get any further than the switch port. Now, above and beyond just identifying who users are before giving them access, we can also do assessments of the workstation. We have the ability to specify what our requirements are and then do a posture assessment regarding that device. And if the device is compliant, great, we can dynamically allow that traffic in. If the device is not compliant, we have additional options, including not giving them any access or maybe putting them in a special VLAN where they can get the tools they need and the updates they need to become compliant, and then they can try again. So all the information regarding what happens to this port, regarding the VLAN assignment or dynamic access control lists that are applied to that port, can all be part of a big if-then statement. If the authentication is correct and you're compliant with our policy, then we'll go ahead and put you in this VLAN and allow your traffic to come into the network. Or if your authentication is correct, however, you're not compliant with our requirements, we can push down a policy to the switch to put this port in a specific VLAN for remediation, like a quarantine VLAN, where they can get the updates and the fixes that they need before they're given full access to the rest of the network. One of the secrets of using ISE as a backend authentication server is to make sure you have it installed, and there's several options for installing ISE. It's very likely that we're going to have it installed on some type of a VMware platform. And for a lab environment, we could go ahead and use VMware Workstation. And if you do not have a copy of VMware Workstation, you can actually get an eval for 30 days directly from VMware. The current flavor is VMware Workstation 10. Another option is that we could use an ESXi host. And the ESXi host also has an eval version that you can use, or you can also get a free license for a standalone ESXi host right from VMware. And in preparation for this video, I actually installed ISE on both of these platforms, and it was successful on either one. Now, a couple of caveats. When you do install a new virtual machine, either in VMware Workstation or on the ESXi host, go ahead and give it a 200 gigabyte hard drive. Now, you might be saying, Keith, 200 gigs? I don't have 200 gigs to spare. In a lab environment, you could go ahead and set that up as being thin provisioned, which means it won't really use the full 200 gigs. It'll only use as much as the virtual machine is really using at any given time. If you set the size at less than 200 gigabytes, for example 120 gigs, again still using thin provisioning, it's going to give you a little warning saying, hey, you know what, this isn't meeting the recommended guidelines for disk storage. But at the end of the day, in a lab environment, we're not going to get close to using that much disk space anyway. The other thing that you'd want to have is you'd want to have 4 gigabytes of RAM available for this new virtual machine, this ISE server. And if you have more RAM, you can throw more at it. Now, in these virtualization environments, VMware Workstation as well as on the ESXi host, you can only give a virtual machine as many cores, logical CPUs, as the host has. So on my VMware Workstation, I've got 4 cores. And for the ESXi host, I had this really fun little HP microserver that only has 2 cores. And so I used 2 cores on that, and it installed fine on either one. I will tell you though, that the one with 4 cores was a little bit faster. And you know what, in a lab environment, you and I are not really after amazing speeds. We're after basic functionality so we can practice and test setting up and configuring ISE in an 802.1x environment. The other thing that I found made a difference is SSD. My VMware workstation, which had the 4 cores, it also has SSD drives in it. And the ESXi host is using traditional spinning drives. And as a result of probably the 4 cores and the SSD, the installation on VMware Workstation of the virtual machine for ISE went a lot quicker than it did on the standalone ESXi host. So as a result of the faster performance I'm personally having with VMware Workstation because of the cores and the SSD, and because I'm strongly encouraging you to also lab this up, and it's very likely going to be easier for you to spin up VMware Workstation rather than get a whole dedicated ESXi host, I'm going to be using the ISE server that's currently running on the VMware Workstation 10 for the balance of this course. And the software I used was the ISO for ISE. It was like 1.2. something. And that ISO, when you do a brand new install, it comes with a built-in evaluation period that starts the clock from the day that you install it. So for most companies that are currently running ISE, you've got your user accounts at CCO, you can download the ISOs and use those. However, if you're an individual or a customer who has not purchased ISE and are not currently using it, if you contact your Cisco reseller, they should be able to get you access to the ISO for evaluation purposes. Now, one of the questions I can just feel it coming up is, okay, Keith, could we do this inside of VirtualBox? And I personally have not spun this up inside of VirtualBox. It is possible that it may work, I just have not personally tried it. Now, the other question that might come up is, okay, Keith, how do I install a new virtual machine if I have the ISO? How do I install a new virtual machine inside of VMware Workstation? Or how do I install a new virtual machine as part of an ESXi host? And what I think would be the most effective use of your or my time is to refer you to the VMware VCP 5.5 course. The first 2 videos walks you through the installation of a virtual machine inside of both an ESXi host as well as VMware Workstation. So if you need a quick refresher on how to do an install inside of VMware, please check out those 2 videos. Now, once ISE is installed, it's sitting there. How do we use it? Well, we're going to open up a browser, https:// and then the IP address or the resolvable name of the server that's currently running ISE. So that would be our virtual machine inside of VMware. In my lab, it's 192.168.1.117. It would ask me for a username. I'd go ahead and log in as admin. During the install process of the ISE server, it prompts you for what username do you want to use, what IP address do you want to use, what password do you want to use. And what I chose is a username of admin and a password of nuggetbang23. And then once we're logged in, we'd want to do a couple of things. We'd want to define who our authenticators are. In our example, we have switch 1, which is going to be an 802.1x authenticator. This computer out here eventually is going to be an 802.1x supplicant. And the ISE server itself is going to act as the authentication server. So at the ISE server, we'd want to go ahead and tell it about the NAD device, the network access device, our switch. And we'd also want to make sure we tell the switch about the passwords and the details regarding how to contact and work with the ISE server over the Radius protocol. And these individual pieces are also important to be aware of because in troubleshooting, for example, let's say Bob is sitting at his computer and he can't access the network. Well, what didn't work? Well, was it the supplicant who didn't talk to the authenticator? Was it the authenticator who couldn't talk to the authentication server? And the benefit of us looking at the individual components and putting them together and verifying that they work is that in a production environment, if there's a problem, we can go in and verify the individual pieces and narrow down the problem to find out where the fault is. So what you and I get to do right now is we'll set up some basic connectivity between the ISE device, which is at .117, and our switch, which is at .121. We'll set up a radius connection back and forth between these two devices. For the password, we'll go ahead and use the password of nuggetbang23. And that's the password I'm going to use consistently across this entire course because it'll be easier for me to remember one password for everything. And then we can also create a user account, for example, Bob, and put him in the local database on the ISE server, and we can also test that right from the switch. So the first thing we're going to do is from a browser, we're going to go ahead and connect to the IP address of our ISE server. And if we don't put HTTP, it will redirect us to HTTPS. And because the server has a self-signed certificate, my browser says, hey, you know what? I've been given this certificate. I can't validate it because it's not from a CA that I trust. And this is the type of message which hopefully our users know to go ahead and not continue. However, in our case, because that is the IP address of our ISE server and it does have a self-signed certificate, I'm going to go ahead and click on continue to this website. I'm going to log on as admin and the password that I set during the setup of ISE and click on login. And I've got a little happygram in the middle of our screen that says, do you want to run the setup assistant now? I'm going to say, nope, we're going to do it all manually, but thanks anyway. And I've got some alarms that are going off. I have an NTP synchronization failure, probably because I didn't configure an NTP server. I've got a little warning message saying, hey, I haven't had any authentication activity for quite a while. And that's because we haven't configured anything yet. This message here is because I have a 120 gigabyte virtual hard drive instead of the 200 that it wants. And I haven't configured a backup yet. And for our lab environment, I'm okay with that. Inside of ISE, we have the Home tab. We have the Operations tab. If we hover over that, we have a drop-down menu of additional options we can go to. We have Policy, and we have Administration. And to start off, let's create a network device group, just a logical container or group that we can put our network access devices in, such as our switch. So we'll click on Network Device Groups. So here under Network Device Groups, if we expand this tree, and we click on All Locations, let's add a brand new network device group. We'll click on Add, and let's call this NugLab Vegas, which happens to be where my home office is. We'll click on Submit, and now we have this device group. Now the problem with this device group is that it's absolutely empty. If we want to add a network access device and put it into this group, we'd go back to Administration. From the drop-down, we'll select Network Devices, and then we'll simply click on Add to add a brand new network device. Let's call this Switch 1. Its IP address is 192.168.1. So here at the switch, let's take a moment and just verify the IP address on this switch, which is switch number 1. I'm going to do a show IP interface brief. Please exclude anything that has the word unassigned in the output of that line. And right here we have the IP address of 192.168.1.121. I think another great idea would be to go ahead and ping just to verify we have basic connectivity between this authenticator, the switch, and the AAA server, the ISE server. So we'll do that with a ping of 192.168.1.117, and that does, and that does not look like a great start. So I need to figure out what's going on with that. So VLAN 1. Let's make sure I can ping something else. Let's do a ping of like a default gateway at 1.1, and that works. And let's go ahead and ping 117. So I'm not sure at the moment of why that first set of pings did not work. Which in the back of my mind raises a little bit of a red flag that I want to be aware in the future about basic connectivity if we have to do any type of troubleshooting. So now that we've confirmed what the IP address is, let's go ahead and put the IP address right here. So on the ISE server, we're going to specify that this network access device is at 192.168.1.121. And because we did create that device group, we can use this drop down under location and specify NUGLab Vegas. So at this point, the ISE server knows about this switch 1 at this specific IP address. However, we haven't told the ISE server about what passwords to use for the radius communications going back and forth. Now, radius is done over ports 1812 and 1813. And by default, most of the traffic is not encrypted. However, the credential information, for example, Bob's password, that is going to be encrypted. And that's one of the differences between TACACS and Radius, is that TACACS encrypts the entire session, while Radius is only encrypting important critical bits like passwords and credentials. So the password we're going to use is nugget exclamation mark 23 with a capital N at the beginning. And there's this really cool button called show, so we can verify that's the password we typed in. And we'll go ahead and submit that. So now our ISE server knows about this network access device. It knows about the password that it should be using with that device. And if we want to test this, we need to create at least one end user account. And to do that, we're going to go to Administration. And from the drop down under Identity Management, we'll go to Identities. We'll select that, and from here we'll select users. And there currently aren't any users, but we can add one by clicking on the green plus symbol. And let's create a user account for Bob. We'll put in his password of nugget exclamation mark 23, and we'll confirm it. And then we could fill in other details about Bob if we wanted to, but for now we'll go ahead and simply click on submit. So now we've done three things on the ISE server. We've created a group, we put a network access device in that group, and we've also created an individual user in the local database of this ISE server. Next, let's go back to our switch. And at the switch, I'm going to hit the up arrow key, make sure we can still ping, and then we're good. And on the switch, let's do some housekeeping. I'm going to set the enable secret to be nugget exclamation mark 23. And I'm also going to turn on AAA new dash model so we can use the advanced AAA functionality. Let's also specify the default method list with the syntax AAA authentication login default enable. So what this says is that our default method list for login is going to be the enable secret, and that's the enable secret that we set right here. The basics and the fundamentals for creating method lists and using them are all contained in the CCNA security course. So if you feel like you need to brush up or review your basic AAA commands for authentication, authorization, or accounting, I would refer you back to CCNA Security for that content. Next, let's define a radius server. Let's call it ISE, and we'll specify that the IP address is 192.168.1.117, that the authentication port is 1812, and the accounting port is 1813. Now this $sign there is because the line is too long. I'm going to hit the up arrow key for a moment, and then Control A so you can see the beginning of that command sequence as well. So if these two devices were not on the same subnet and there was a router in between them, we'd want to make sure that any access control lists are permitting these ports between the switch and the ISE server. And we're also going to specify the key that we're going to use with that AAA server. You know what the best key to use is? The best key is the one that matches up on that AAA server. So because we told the ISE server that this network access device, the switch, it should use the password nugget-bang23, we should use that same password right here as we communicate up with the ISE server. Let's also create a AAA server group for Radius. We'll call it ISE group, and we'll put into that group that one Radius server that we named ISE. Now, there is more than one single way to configure a switch to talk to a radius server or a group of radius servers. Now, because we're going to need it eventually, I'm also going to add the radius-server VSA send authentication and accounting command. Now, VSA is vendor specific attributes. And as we start adding on additional features, specifically Cisco features, as part of 802.1x, we're going to need those vendor specific attributes to be sent. We're also going to need IP device tracking, and that allows our switch to maintain and build an IP tracking table regarding detected hosts as they authenticate and connect to the network. So now with the switch knowing about ISE and the ISE server knowing about the switch, we should be able to test basic AAA services between the switch and the ISE server. And let's do a debug just for fun. We'll do a debug of radius. Take a look what our options are. We'll just press enter, which will give us radius protocol debugging, which is great. And we'll use the command test AAA group, the name of our AAA server group, the username Bob, the password nugget bang23 new dash code, and hopefully that'll be successful. And look at that. We are not having success. I love it. I love troubleshooting. So let's go back. There's our user Bob. If we go back to administration and network devices, here we have the IP address of our switch. And on the switch, so here we have our request to 192.168.1.117 port 1812 for authentication. The user password is hidden in the debug. The username was Bob. And the NAS address, NAS in this case stands for Network Access Server, a device that provides access to the network. Currently we're now calling these NADs, Network Access Devices, but that's okay. That's our IP address, the IP address of the switch. It timed out. It tried a couple more times, and as an end result, it failed. Wow, I think we may have a connectivity problem between us. Let me try a ping one more time. Hit the up arrow key a few times. Yeah, look at that. I honestly don't know where that is. This is a very small lab environment. It's in the other room. I'll have to go check it out. However, because our basic connectivity is failing, it's also causing our test to fail. So let's do this. Let's go ahead and ping our default gateway, just to verify we have connectivity to something on that subnet. So as far as troubleshooting goes, here's our command line prompt for the ISE server itself. And so we can log on as admin. And we can do a ping of 192.168.1.121, which is the IP address of the switch. Okay. Wow, so the ping works in that direction. Let's go back to the switch. And at the switch, let's try to ping 117. Okay, so I've got some kind of an intermittent problem with basic connectivity between the switch and the ISE server. So I've got some wireless in between those devices on that network. I'm going to go ahead and reconfigure that between this video and the next one. But for now, as long as we have basic connectivity, let's go ahead and run our test once more. Test AAA group, ISE group, Bob, Nugget Bang23, new code. And that looks a lot better. So there's our test, there's the username, and it says user successfully authenticated, and then we have the details from the debug regarding the play-by-play. So in this video, we've identified some vocabulary associated with 802.1x. The supplicant who's supplying credentials, an authenticator who's requesting those credentials, and a backend AAA server acting as an authentication server, in this case being played by ISE, to validate those credentials. We also looked at our options for installing ISE in a virtualized environment, either in a lab environment with VMware Workstation or on an ESXi host. The VMware Workstation, if you don't have a license for that, you can get an eval from VMware. And for a standalone ESXi host, you can also use an evaluation of that, or VMware will give you your own license for free for a standalone ESXi host. We set up a local user account on the ISE server of Bob. We configure the switch and the ISE server to know about each other, including what password to use for Radius, and we verified that with the test AAA command. Our action items for this video are simple. I am strongly encouraging you to set up your own lab environment so you can get your hands-on practice working with the Identity Services Engine. And if you need a little push or nudge as far as how do you install a new virtual machine in VMware Workstation, again, check out the first 2 videos of the VMware vSphere course right here at CBT Nuggets. I have had a great time. I'm so glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.